For this problem, we've been given a polynomial equation, x to the 7th minus 9x to the 5th equals 0, and we've first been asked to state the degree of the polynomial. When we have an equation that is in one variable only, meaning here that we only have x's in our problem, the degree is the highest exponent that we see. So for this one, 7 is the highest exponent that we see, and the degree of the polynomial then would be 7. Now, knowing the degree is very important because we can use it with the leading coefficient test to determine the left and right-hand behavior if we were to graph this as a function. Since this particular polynomial has an odd degree with a positive leading coefficient, remember there's an understood 1 up here on the front, positive 1. If you've got an odd degree with a positive leading coefficient, the graph would be down on the left side and up on the right side. Things that have an odd degree have the two sides doing opposite things. O for odd, O for opposite. And if it's positive for a leading coefficient, the left points down and the right points up. Now, the next thing we've been asked to do with this particular problem is to find all of the real and imaginary roots or solutions for the equation, and then to state the multiplicity of each root that we have. Well, anytime that we're trying to find solutions, we always want to try to factor if we can. That's the fastest way for me to get to the solutions. I know that I can factor this one at least a little bit because I see the x that is common to both of the terms here. In fact, it's an x to the 5th that is common. When we factor that x to the 5th out, it would leave x squared minus 9, which of course factors again as x plus 3 and x minus 3. Well, now that we've got it completely factored, we can find our solutions by setting each of the factors individually equal to 0. Anytime that you've got a common x, regardless of what exponent is attached to it, a common x will give you 0 as a solution. So x to the 5th is 0 as a solution or root. The multiplicity is the exponent that is attached to the factor. So for x to the 5th, the exponent is 5. That means 0 has a multiplicity of 5. Look at the next factor that we have, x plus 3. If we take x plus 3, set it equal to 0, and solve, we would get negative 3 as a solution. To find the multiplicity for negative 3, look at the attached exponent. It's again an exponent here of 1. So since we've got an exponent of 1, that means 1 is the multiplicity for negative 3 as a solution. Then our last factor, x minus 3. If you set x minus 3 equal to 0 and solve, you would get 3 as a solution. What's the attached exponent? 1 is the attached exponent, so the solution of 3 has a multiplicity of 1. Now, why would we want to know the multiplicity? The reason the multiplicity is important to us is it tells us on a graph whether we pass through the associated x-intercept or whether we bounce off of it. We'll bounce off of things that have an even multiplicity. We'll pass through things that have an odd multiplicity. Look at our multiplicities again for this problem. 5 was the multiplicity for 0 as a solution. 1 was the multiplicity for negative 3 as a solution. And it was also 1 as the multiplicity when positive 3 was our solution. All of these have an odd multiplicity. So if we look at a graph, we would expect for the picture to go through each of the x-intercepts. Let's see if that's true at graphsketch.com. Here is our picture. It's shooting off of our grid here up at the top and also over here down at the bottom. But notice what's happening. We're passing through these x-intercepts. Here is the x-intercept for negative 3, and we've gone through it. Here is the x-intercept at 0, and we've gone through it as well. Then over here at positive 3, we're going through from one side to the other for that one as well. Odd multiplicities we pass through, even multiplicities we bounce off of. Notice that the picture was pointed down on the left-hand side, up on the right-hand side. So knowing that we had an odd degree and a positive leading coefficient did tell us left and right-hand behavior.